Today we want to look at some problem-solving skills. We would like to calculate a percent change and solve using a formula. Let's begin with a percent change problem. Let's calculate the percent change for P1 is equal to 8 and P2 equal to 13. Let me give you a little background on this problem and how exactly it works. Let's say you go to the store today and you buy a bottle of vitamins and they cost $8. You go home, you take your vitamins one a day for the next ever how long they last. And then you go back to the store to buy the vitamins the next time. You buy exactly the same vitamins. This time when you check out, you find that the price is $13. And you say to yourself, goodness, that's a huge increase in that price. I wonder what percent that price changed. That's what a percent change is asking. So what we want to do today is we want to calculate what is the percent change for that $8 bottle of vitamins when it changed to $13. In this case, before we even start, I want to point out that since the price went from $8 to $13, we are expecting a positive percent change. To do this problem, we need a formula. The percent change formula is P2 minus P1 divided by P1 times 100. So let's start. We literally plug those numbers in. Notice our P2 is 13. P1 is 8, it goes in both of the places, and then we still need to multiply by 100. When we do those operations, we get 0.625 times 100. Let me remind you, if you're doing that on your calculator, please remember to put the numerator and the denominator of that fraction in parentheses so that you will get the correct answer. Once we have the 0.625, we need to multiply it times 100 to change that number to a percent. When we do, we find that we have a 62.5% change in the price of our vitamins. If you were working a percent change problem and the price had dropped from $13 to $8, then you would expect to get a negative percent change. Let's look at another type of problem. This one is one where we'll use a formula to solve. This time we have the volume V of a cylindrical soda can is given by V equal pi r squared h, where r is the radius and h is the height. If r is equal to 1.4 and h is equal to 5, find the volume of the can in cubic inches. And then, if 1 cubic inch is equal to 0.55 fluid ounces, could this can hold 16 fluid ounces? So let's begin by calculating the volume. The formula which they gave us is V is equal to pi r squared h. And they gave us the following information. R is equal to 1.4 and h is equal to 5. We plug those numbers in and your formula now looks like this. I want to encourage you to use pi on your calculator, not 3.14. You'll get a much more accurate answer. Remember, the pi key is right underneath the clear button, so you'll do second caret to get that key. When you do that calculation, you come up with V is equal to 30.8 cubic inches. I want to talk to you for just a minute about that unit of measure, cubic inches. In this problem, you've multiplied inches times inches times inches. And when you do that, what you get are cubic inches. The same as you do with square feet, for example. If you multiply feet times feet, you get square feet. So what you have here is 30.8 cubic inches. Now we need to answer the last question which they ask us, which is, if 1 cubic inch is equal to 0.55 fluid ounces, could this can hold 16 fluid ounces? Well, each cubic inch is 0.55 and we have 30.8 of them. So we need to multiply those two numbers together and we get 16.94 fluid ounces. Answer the question for us now. Could this can hold 16 fluid ounces? Well, we see that it actually can hold 16.94 fluid ounces, and so our answer to the question is yes, this can hold 16 fluid ounces. Those are the only two problems we're going to look at today for problem solving. I know this one was really short, and I know you're relieved, but I'll see you back soon. Have a good day.